next question comes in the exam. Next question comes in the exam is on the timing diagram. Timing diagram is a graphical representation where the execution time taken by each instruction shown in the graphical graph. The execution is represented in the form of a timing T states. For example, first we will see the control signal. What are the different control signals? I oblique M bar as well as this signal already represented in the pin diagram. Now the I oblique M bar and S1 S2, suppose they all the three are 0 0 0 0, then halt condition is there, data bus is in the halt state. When 0 0 1 is there, then it is in the memory write condition. When 0 1 0 is there, then it is in the memory read condition. When it is 1 0 1, then it is in the IO write condition, means input output write. 1 1 0, when it is in the IO read condition. When I oblique M bar 0 1 1 is there, then in this condition it is upcode fetching, means it is getting the upcodes of the instruction, and 1 is for the interrupt acknowledgement signal. Then next comes the instruction cycle. The time required to execute an instruction, a single instruction, is called as the instruction cycle. Machine cycle. The time required to access the memory or input output device is called the machine cycle, means in instruction cycle the time required for the execution of a single instruction. In machine cycle, the time required to access the memory input output device is called the machine cycle. Then the T states. The machine cycle and instruction cycle takes multiple clock periods. Clock periods denoted by the capital T. A portion of an operation carried out in one system clock period is called as T states. T states. A portion of an operation carried out in one system clock period is called as T states. Note: time period T is equals to 1 upon the frequency. Internal clock frequency is there for each and every processor. Rising edge and falling edge with the negative edge, they are rising edge is called the positive edge and then falling edge is called the negative edge, and the complete one is referred as the 1T state, that is for this distance from this distance forms 1T, so this distance is referred as the 1T state. And in 80 microprocessor there is 5 basic machine cycles are there: upward fetch cycle 4T states, memory read cycle 3T states, memory write cycle 3T states, IO cycle 3T, and IO write cycle 3T states. The processor takes a definite time to execute a particular machine cycle. Then that time is defined by the term of T state. One T state is defined in the terms of time period that is dependent on the internal clock of the processor. The T state starts at the falling edge of a clock. Suppose upcode fetch operation of a machine cycle for 8085, the clock will remain the constant. It will T1, T2, T3, T4, and higher order memory addresses and unspecified. Then AD0 into A8 are the higher order memory addresses, AD7 to AD0 lower order memory addresses, as well as data. It is multiplex address and data line. So it can work as a data buses also, and as well as the address buses also. And address latch enable dependent on this signal, whether it is a data or a memory address. This can be defined by ALT. Address dependent on this page, whether it is 087 is containing the code, other data, or a memory. And I already am bar and S1 are dependent on this folder. Then each instruction has one byte hold, then all these 40 are specified. Hence every instruction starts the operation cycle, and the time taken by the processor to execute the opcode fetch cycle is 40, and in the second instance it is the 3T states. Same way, if a higher order memory and lower order memory, if I represented like this, then it will be modified in the earlier one. Depending on this and depending on this time, T state will vary. Then the process T states. Then same ways the machine cycle can be enhanced by the T states of the and value of S1 and S2 can be varied from 0 to 1 and 1 to 0. The memory write machine cycle is executed by the processor to write a data type data byte in a memory location, the processor takes 3 steps to execute the same. I have written the execution. The processor read a data byte from the input output port and from the peripheral access, so either it is a keyboard or mouse, whichever it is, from that you can read and write. It's logged like this. And next I write the 3D step. Again check this value as 0 as for each. Depend on this table, all the values of S0 and S1 is varied in each and every step. Here check here, I oblique M bar is 0 and it is 1 1 or 1, then it is I oblique M bar is 0 and it is 1 0, then here it is I oblique M bar is 0 and there is 0 1, S1 and 0 value. Here it is again I oblique M bar is 1 and S1 is 1 and S0 is 0. Same is here also, I oblique M bar is 1 and it is in the condition 0 1, S1 and S0. For example, if I want to draw the priming diagram for NVID, then first draw diagram will remain as it is. Then if move B comma for the hex, then I have right here 20 hex, I have right here, and lower order for that, then the operation is that I always have as 0 0 1. Read instruction is there, and again 0 1 and here 40 the data. In this case there is a 0 6 the data, and this the lower data. After this ALE signal, then STF526 upcode fetch, and memory read. There are two parts in each and every instruction. There are two parts. In every instruction there are two parts: upcode fetch and memory read. So the two waveforms can be plotted. Same is the case for STA instruction. This is the upcode fetch type. I oblique M bar is 0 and S0 S1 are on 1, and the same instructions is written here. When memory read comes here, check this out, T5 T6 T7, here it is 4 8 6 8, and same is divided 5 into 6 A, 5 to 6 A is divided into this 2, actually it is 42. I have written here, so 4 to hex consider it 0 1 and 2 like this, all the memory and PG that it will be executed. 0 hex start to 6 hex is